Hey, Erdell.
Yes,
Uh, we see you here, Liz Mazio. Hey, Liz, how are you? Good to see you. How many people are you expecting, Erdell?
I emailed everybody,
Oh,
so I do not, and there was no restrictions on. So I'm assuming everybody who's come still gonna come. That was my assumption.
mm. You saw the email about tomorrow morning on the National Cyber Security Alliance coming on board to talk to our students in Jefferson Building.
No, I did not see that.
Okay. Um, hmm.
Okay. Mm.
Dean were supposed to send it out to faculty and hmm,
I'm just I'm trying to put me on the TV in the room here.
yeah.
If anyone comes, yeah, if anyone comes in, it's not gonna be an issue. Still letting people in as they come. How are you doing today, Mr. Jinwei? That's the best way to be.
Who's presenting today, Ardell?
Technically, it's all of us.
Okay.
And it's deep,
Okay.
but I think you. All right, we have some more people. I think we'll give about one more minute and then we
Okay.
can get started.
Okay. Mm.
And people are still coming in. All right. Good afternoon, everyone. How are we doing today? Hopefully, so far we've had a lovely day. We've been able to meet all our goals, and hopefully this afternoon is just going to be nice and calm, nice calm afternoon. Welcome. The reason why we're having this part of the workshop is we wanted to get across two main ideas. One, we wanted to give everyone an opportunity to kind of describe what their research is and how they may see data science or artificial intelligence or machine learning fitting into that area. And then we could hopefully give you some guidance on how to put that into action, or give you at least a starting framework to help you jumpstart your work in that area, if that's what you're looking for. So if it's resources that you need, if it's I'm starting from scratch and I have no idea where I need to go, or databases that you need, or I don't know, we can at least try to help you figure out where to go and get that process started. Because most of these things right here is not, we can work together to make that happen. And so today is kind of our first step in making that happen. But before we get going on that, Dr. Alo wanted to say a few words. I'll give him the floor right now.
Okay. Thank you, Ardell. And hello, everybody. So glad to see you. Um, really excited about your participation. Very, very excited. You know, our grant that is sponsoring this is let me tell you a little bit about that grant. It is a grant coming from the U.S. Department of Commerce in their division called NTIA, which is the National Telecommunications and Information Act. And in that is a department set up by the Biden-Harris administration called Connecting Minority Communities. And that is the grant that is sponsoring these workshops. I'm a co-PI on that grant. And on that uh, grant, my objectives are building called Big Data University K through 20. So with this funding, we are doing these workshops, which you are attending, and we're very, very pleased to see you attending these. We're also infusing data science and discrete mathematics and artificial intelligence in the K through 12 curriculum with our developmental research school. And we're also creating a pipeline program for the developmental research school, beginning with seventh, eighth grade students, cohorts of students that will be involved in STEM engagement, discrete science, AI engagement uh, over the summer for 4 summers, uh, over 4 summers until they become rising seniors. And hopefully, we are looking that they become college curriculum, STEM curriculum ready. But back to this particular meeting. As Erdal said, we do want to hear what your needs are. Our team can respond to those needs and help you. We do want to help you in whatever research you're undertaking, and if you need help on the tools, as you've been learning about the tools, what's available on the National Data Platform, what's available on the National Artificial Intelligence Research and Resource Platform. We're here to help. And right now, we have heard from some of you. And so we will continue these sessions next week and the week after spring break. In particular, there is a flyer that will be going out that will talk about uh, Python. The request was to get do more work on Python. So we're pleased to get that request, and we're pleased to be able to offer additional sessions here. So a flyer will be coming out. Phase 1 will be next week, next Wednesday, as you see, at 3:30. And those are the topics. We will send this flyer out to you and others. And then the week after that is spring break. So there will be no session during that week. But the week after spring break will be another session, and that'll be phase 2. Okay, so that's the agenda. Now I would like to tell you about, we mentioned at the beginning that we are hoping that everybody that completes these sessions, we are hoping to give you a small stipend. What we are waiting on is the grant, this particular grant expires at the end of this month, but we have the request in for an extension, an automatic extension. Now, you all are aware of the news that's going on at the national level. Yeah, so, I cannot commit, but I will tell you that we did encourage in the budget a small stipend for people completing these sessions. Okay. Once we know the status of our extension, as I said, the current cycle is on this particular grant is at the end of this month, which is coming up this week. And the extension then is being requested for 1 year. And in that extension, we will continue doing workshops for faculty across the campus. So let's go back to the small stipend that we hope to give people, which depends on, the status of our renewal. I don't want to get into any discussion about what's going on at the national level, but we just need to be alert and we just need to pay attention, and hopefully we'll get through this. But what we do need then from you, and Erdal will try to collect this information. We need the names of each of you and your ID numbers, um, and then we should be able to process that once we know the status of this of our situation. It's exciting news. I'm glad to be able to that we did put this out there. We did put it in the budget, but we just have to wait to be sure what happens at the national level. Okay, so I am going to turn this back over to Erdal. He'll gather the information, and we'll go from there. Erdal, did you want to add anything about the phase 1 and phase 2 for people?
No, it's just please come. You're always welcome to come right here. Python is one of the main languages used in artificial intelligence and machine learning. And so as good a grip as you can get on Python as you can, certainly will help. And so please do come.
Okay. So you want to continue on with the agenda then, Erdal?
All right. All right, so yes, so today hopefully will be a little bit freewheeling. In a minute, I'm going to call for a volunteer to kind of describe, what they're doing and what. So basically, what we're looking for is what you're doing, um, what kind of data sets that you have, and what kind of outcomes that you're looking for, and then we can kind of go listen and then discuss and figure out, hey, what ways we can help or what can you do to help take that next step. So I am looking for a volunteer. Let's go first. All right. Do I need to call on somebody then? Or do you want me to get started? I can get started as well. Let me see. Oh, you can put in the chat if you're not in a place where you can talk right now.
I think that's a good idea if they put it in the chat and we respond, because then we can have a record of it, Erdal.
Okay. Yes.
Yeah.
Either way will work for me. I was going to take notes.
Yeah, that's right.
Really, we're recording as well, so
Exactly.
we will have a thing either way. All right. So then we can go to plan B. If I don't have anyone in particular. Okay, so plan B would be then, do you have any questions in general, things that popped up, things that you learned about that you wanted to know more about? Any questions there? No questions coming to mind. I can help motivate some questions. Let me stop sharing screen right there. All right. So, Dr. Mativa, how are we doing today? I'm going to pick on you since, we've already started. Can you hear me?
Yes, I can hear you. Hold on. Okay, yeah, I knew that, of course. Yeah, believe me, we feel like, those students who are now hiding behind their desks. Anyway, so what would you like to be talking about?
All right. So, any of your research areas that you think you may be able to apply some artificial intelligence or anything in particular?
Right. So there are a couple of things here. To apply artificial intelligence in teaching might be one of the first things that I'm aiming at. And I believe it's not me only. I'm not talking about pharmacy people who, they aim more exclusively at research, but doing this and applying some small projects in your curriculum might be a task which is easily achievable. Well, I think so. I haven't tried, but I think it's easily achievable anyway. So, and I believe we discussed something like this. For example, to incorporate a small project in our bigger project, lab or lecture course. And then when we discussed that, I think this was using Jupyter Notebook, was it? Yeah. So this will be one thing I would be interested in. I can come up with a small data set which can be used to predict certain number, and we can use the tool to predict the data based on this is structure property relationship basically. And then under lab conditions we can combine this with hands-on experience, asking students to obtain the same thing hands-on and compare with real data. So this is one thing. The second one would be I'm involved in drug discovery and research as well, similarly to my colleagues from the pharmacy department. So with this respect, the protein folding will be something very interesting that, we just started. We did some baby steps on it. I'm looking at this. I was not very functional, sorry, last week, but I keep looking at that and seeing, I think that very interesting things can come out of this. In addition, I wonder if we can use this um, for prediction of drug properties, and those guys from pharmacy can tell us much more about that. And there is a third thing, well, third and fourth, and there is so the third thing, let's put it as number 3. Using small data sets where large data sets are not available. So for many chemistry areas, such as analytical chemistry, for example, for certain, or material chemistry, to predict certain properties, we don't really have enough data. So I want to see how using some small data sets that are available can lead us to better conclusions about the conditions that we can use to create certain material. I mean, I can keep going on and on. There are plenty of things that we can do about this, but I'm going to stop here and allow others to talk.
All right, so let's kind of go back through those a little bit. So for the teaching, the nice thing about most of the data science tools is that they are designed to work with large data sets, but they will work with small data sets. Although your accuracy might not be as high as you want. You may
Mhm.
it may not be over like 95% accurate, but since the teaching process, that's okay. That's not the point. The point is to just get us through that process where we have a starting point, we have a database,
Mhm.
clean the database. We look at the database from different angles, tables and charts and line graphs, and then use different tools to either do machine learning or artificial intelligence, right? Because one of the interesting things is that building a neural network, although it may not be as efficient as a machine learning model in some areas, but just going through the process of building one, seeing the different nuances can really help. And so that's definitely something that we can work on. And the nice thing is that not only as students can learn, but you can learn from that as well, because the process will be the same, even though you're working on a large data set. All right. So yes, literally all we do need is the data set, and then from there, everything can flow from there in terms of the small projects. Um, as for the protein folding, I've been talking to you for a little bit already, and I've done a little bit of work looking at AlphaFold 2. That's Google's protein folder.
Mhm.
And
Yeah, I saw that.
Yes, and there's also this other group. They created a basically what happens is that they have a set of predefined smaller protein sequences, and they use those sequences to help improve the prediction of the protein fold. And they got it to be like what, 10 times faster or something like that. It only takes like 20 minutes to fold a protein. But for that example, what happens is that there's already work out there that has been done. What we need to do is to build on that work to either kind of like what you did in the second piece right here, third piece right here, is to work with areas where a small amount of data is. Like, maybe protein folding for a certain small aspect of the human body, or working with fly DNA or whatever, or working with, say again?
A little louder.
Oh, sorry. Or working in any of those areas. The point is a lot of the hard work has already been done. The question is us adapting it to what we needed to do or what we're looking for. So we may need, those things can be done. The last thing that I want to point out right here is that we ourselves can do research as well. So if you have a small data set, we may have insights that can allow us to improve the prediction of the current neural networks that are already out there. In fact, that's what the people did with AlphaFold 2. What happened was they recognized that, hey, AlphaFold is always checking the entire database. If we instead simplify the database and then only check, say, 3 areas instead of the entire database, that could significantly reduce the amount of time the process will take. And they did it, and they got actually better results or similar results and AlphaFolds. And so, one of the things we can always do is try to improve on what's already been done. Okay. Any comments on so far what we talked about so far? I have someone in the chat. So I have someone says, I was wondering if we can use our student data and use machine learning to mine for information. And the answer to that question is yes. And it's actually one of my current research projects is to actually predict students' grades based upon their work before the test. And so, for example, in my college algebra course, I take their homework and their quiz grades, and I use that. But the target grade is the test one grade, and I use that to predict their grades. So literally, I had about maybe 900 lines of data, not a whole bunch, about 2.5 years of data. And even with that small amount of data, I was able to predict with, I think it was 85%, my error, I was 85%. And so actually that's almost a letter grade. It's about a letter grade accuracy, which is good enough. I can say, hey, you're gonna get an A, you can get a B, or you can get a C with that. And so the answer is definitely we can do that. My theory is that our grade books are AI gold. If you think about it, we have been keeping grade books for decades now, if not centuries. And literally all we do with the grade books is throw them away at the end of the semester. And if you think about it for a second, the answer is definitely we can use those to mine for data and also use them prediction and analysis of our students.
Okay, so I'm like, is it okay to ask
Go
a
ahead.
question? So I'm wondering that we have all the, the data that we submit for state level and all that. So uploading that kind of data, which is a lot, um, is it possible to find associations that we otherwise don't find, unless you write specific programs, it's hard to find associations. Like if students are transfer students with this GPA and taking this course with whatever the letter grades they get, what are the chances of them graduating in 4 years? Those kind of questions. Is it possible to like upload files and write this in English and have your Jupyter or Google Colab write the code for it?
All right, so that's an interesting question. One of the things that, and maybe you heard this before, but a lot of our AI solutions are what we call black box solutions.
Right.
What we mean right here is we don't know how they're doing it,
How they do it, right?
but we know that their answers are correct, right?
Okay.
Right.
Mhm.
And so this is one of the nice things about AI is that for this kind of a question, literally, it can get you to an answer and an answer that's actually plausible without us having to go through any long process. So
Got it.
literally you just upload the data to the neural
Right.
network. You have your target column. Say, for example, you want to predict whether or not a student will graduate in 4 years, or you want to predict the number of years till graduation for a student, right?
Right.
And so literally you'd upload all the data that you have and put it into the neural network, and the neural network will simply minimize the error, and that output that it'll give you will tend to give you a good answer, especially
Right.
if you have a lot of data. So
Right.
it is something that can definitely be done. The one thing that I will add to that is that in my previous discussion right here, in terms of using student grades to predict their test scores, sometimes if you have more data, you can use that to improve the accuracy. So
Right.
instead of me, for example, just getting more test data, if I can get, for example, students' high school GPA, if I can get students' actual what they call major, if I can
Right.
get those other grades,
Right.
right here, that can
Mhm.
actually help improve the model. And
Absolutely. And we have that. So we have all of that information. But like last time I had asked, and I got a reply that if we remove sensitive information, then we are okay to upload the data at the NRP.
yes, normally that's the case. Normally, if you de-identify the data, then generally speaking, you can work with the data, especially if you're using it for university, for university resources, university reasons. Generally speaking, that's fine.
That's fine. Okay. Thank you so much. This was great. And thank you for all the sessions. Really enjoyed it.
Yeah, so what I would add is that then a follow-up is needed. So send us an email, and then we'll try to find a time so we can maybe sit down and get some kind of process started.
Great.
Oh, Maurice, can you hear me? Yeah.
Yes, go ahead. Yes, go ahead. But yes, to get some kind of process going.
Okay, I was just wondering, we actually purchased, we're just trying to set up our facility with AWS, which is quite a lot of work to do for Amazon.
Yes.
So we're going to have a general account now, soon. Very, very soon.
Mm-hmm.
So she was just talking about regulations and security issues, right? I can't really hear much going on here. Yeah. So instead of, I mean, we can also have that as an option as well for using Amazon AWS, like S3 Cloud.
So for this, yeah, so previously, our lab purchased the computing resource and the storage resource from Amazon AWS, and yeah, there are some echoes.
Yeah.
Definitely, we can. Can you? Okay, definitely we can use I mean the instance from Amazon AWS. We can we can so first you will need to I mean you will need to probably talk with the technician at AWS. Then he will you can discuss the price and the instances with the technician. Then I mean, he or she will be help you set up the AWS. And at that time, our lab purchased the instance from AWS, and also we purchased data volume. The data volume is used to store the data. We purchased 1 terabyte data volume, and you know, they will charge us based on the. I mean, they will charge you based on the instance, the type of instance, and also the time that you use, that you have used the service. So yeah, I mean that.
Dr. Liu, I have a question for you because we're a little ahead of you on that. So we already have everything what you just said has been done, except for we're piggybacking off of the Omnia contract. The university uses Omnia, right? Omnia for discount price?
Could you please repeat it, Amir? Could you please repeat it?
Right. Okay. So here's the situation. We had a meeting, Dr. Reams and I, with AWS and the whole IT department. Because they were telling us that there was nobody really at FAMU so far. Well, I don't know. It's like everybody, we're the first people to get AWS in the procurement system. So nobody's really paying AWS right now.
So wait, let me
through sponsored research programs.
Right.
So for this,
Jinwei, let me interrupt just a moment. Yeah, thanks, Liz, for bringing this up.
Talk a little louder,
So
please.
my question is, before, please take a look at what's available on the National Research Platform, because the resources within the National Research Platform and within the National Artificial Intelligence Research Resource environment are free for our institution. Matter of fact, that's one of the focal points of the National Research Platform. These are free, unlimited shared resources in cloud, in data, exascale computing modules and over 1,300 graphical processing units. These are free for institutions like ours, and specifically that goes as underserved and under-resourced institutions, and they are free for research and learning environments. And so can we check, Erdal and Jinwei, what the requests that pharmacy has, are these available? Are they available on the NRP? Are they available within NAIRR? Can you check that?
I think, see, we set this up for high volume data analytics, like from sequencing. This is actually our sequencing machine. And this machine here has to be connected to a cloud. We're just working with all the workarounds with this, but the S3 has a data pipeline for genomics and sequencing. That now I guess Amazon is on board with that, but we can probably try it. But this machine is so crazy that it's automatically data dumps the data up onto the cloud. It doesn't even allow us to schedule when that data. It's going to be after every run.
And see, on the NRP, you do have cloud resources. I'm sorry, I'd love to carry on this conversation with you, Liz. I've got to run to another appointment, and so I need to get off this, but can we set up another time, Erdal?
Absolutely. This is yeah.
Yeah, I'd be glad to work with you on this. Okay.
Yeah. So
I
think
really got to run. So Erdal, Jinwei, can I leave this with you all and get back with Liz and whoever else needs this resource, and we can work on it with them. Okay. I'm sorry, I have another appointment. Okay.
Thank you so much, Dr. Allo.
Yes, we're here to help. Okay. Thank you.
Yes, I think what Dr. Allo was trying to say was that how can I say it? Yes, all that's what you're talking about can be done through NRP. The data dumps, having a S3 storage, being able to transfer the data through the cloud, have the data been there, and then you'll be able to access the data to then run whatever analysis you need to run on the data. Okay. That can be done through NRP. I think basically that's what you're trying to say. You know, it's just that it's a new thing. So we may not have been aware of that when you were setting up with the AWS. And obviously, if, you know, NRP is free and AWS, if you need more GPU power, then you can get on the NRP, then, you know, you can also use the AWS as well. But basically what he's saying right here is that the NRP has a lot of free resource, and right now it's been underutilized, and so we're trying to get as many people to use it as possible. So if at all possible, you can use it first, and then if we run out of resources or you need something extra, then you can go ahead and finish it off on AWS.
Okay.
I think that's what he's trying to suggest.
So I want to
Right.
I want to provide some comments because I had this experience. For some projects, they may have there may be some restrictions on the use of the machine due to the data, like the privacy of the data. So so previously our lab purchased the computing resource and storage resource from AWS, but we were not allowed to use our own computer to run, to do experiments, to run programs, because they require us to use the resource from AWS to do experiments. Since we, at that time, our project was supported by DARPA, and we downloaded the data from NADOS, and so we had to use the AWS to to run programs, to do experiments. So I would say probably you can check if you are allowed to use your own machines or the machines from some clusters. Then if they allow you to use those machines, then you can use, probably you can use those machines for cost saving purpose. So basically, at that time, we use the AWS from Monday to Friday, from 9 a.m. to 6 p.m. every day. So normally we were charged $1,500 each month.
No, but now here's my question, because when we were working with IT, we were going through sponsored research for all this, But okay, that sounds about right. Yeah.
Yeah, you can check it
It's
first.
expensive, yeah.
Yeah.
Yeah. We can do as much on site as we can. We just purchased some really good computers, and so it's like a transfer data station.
And
yeah,
if they allow you to use your own computers or the computers from some clusters, then that will be helpful. So at that time, our lab purchased the multiple servers, the GPU servers, the cluster servers, the database servers. At the beginning, we were not allowed to use our own machines, but so we had to pay to pay the service from AWS. But later on, we discussed the people, the people, including the people from DARPA, and they said that we cannot use use the raw data in our in our own computers or the computers from some clusters, but for the process data, we can use them on our own computers.
Okay, I'm going to schedule to have an appointment with you and to talk to you about our pipeline, see if we can do it as much as we can on site. And maybe we can use the NRP, but let's get together. I know exactly what programs we need and to build the pipeline. And yeah, if you guys could help with that, that would be amazing.
Yeah, so I mean, if you use AWS, I have some experience. So yeah, so I mean, so yeah, previously I was responsible for the management of the data and the resource from AWS when I was when I worked as a postdoc researcher. Yeah.
Oh, yeah, and also remember that the NRP itself has a lot of resources as well. And so I think the best option would be to find a time for the three groups to meet, you, us, and the NRP. And so that way they can have an exact, because the key thing where I have all of these things because they're technical, you need to have the exact requirements, and then, we can go ahead and configure it from there. Okay.
Thank you so much.
Anybody else?
So yeah, I work on some research projects. Just now I didn't get a chance to introduce my research, and I think I mean data science and AI machine learning are quite relevant to my research. Yeah, for example, so I work on a research project on healthcare. So basically, I use the machine learning algorithms such as the feature selection algorithms, different feature selection algorithms to identify the health determinants, the determinants that have caused the health disparities, so that it can help to improve healthcare and advance health equity. And also, I work on some other research projects such as cyber threat detection or the detection of cyber attacks. Basically, I use the machine learning algorithms such as support working machine, decision tree, and so on to predict I mean a message such as a message from the social media platforms like Twitter, if it is misinformation, so that it can help to reduce reduce the cost caused by the cyber attacks or cyber threats. And also, I work on the research projects on resource allocation and scheduling in cloud computing. That is quite relevant to machine learning and also big data. So I use the machine learning algorithms such as deep learning, and I first use the deep learning algorithm to predict the amount of unused resource in the cloud computing system, and then we improve the resource utilization by reallocate the unused resource to the other new jobs, so that it can help to improve the resource utilization of the cloud computing system. Moreover, I further use the hidden Markov model to predict the fluctuations of the resource usage of jobs and tasks, and it can help to correct the prediction error, so it can help to reduce the service level objective violation. So that is about the research project on resource allocation and scheduling in cloud computing. Similarly, I work on a project on job scheduling or task scheduling in cloud computing. Similarly, I use multiple machine learning algorithms such as reinforcement learning, and also the support working machine. First, I use the machine learning algorithm support working machine to classify jobs, so that it can it can help to classify the jobs into different categories like short jobs and long-term jobs, so that it can help to reduce the resource wastage caused by fragmentation, resource fragmentation. And also I work on some projects on social networks or social media. Yeah, so basically I use the machine learning algorithms, technicals, and the data science techniques to discover the knowledges from the community question and answering systems. Yeah, so that's that's about my research projects. I think probably my research project on healthcare is more relevant to the the research projects of the people from pharmacy. Yeah, and also previously, I mean, when I was a graduate student, yeah, at that time, I know that yeah, I worked with some professors for utilizing high performance computing for doing sequencing and also the prediction of the structure of glycan. Yeah.
Okay, yeah.
Have you done any spatial genomic analysis?
Yeah, well, I mean, we just simply use the the cluster. We use the parameter cluster from Clemson University, and also we use some machine learning algorithms like lib as well. That is one of the one type of support working machine to do analysis, to do prediction of sequence.
Dr. Liu, I have a question on the bandwidth capacity of the university, because we ran into problems with VP Seniors. He was saying that we're going to get a 10 gigabyte transfer cable, which we don't have in our lab right now. It's just one. But he was saying that we can't transfer, or we can't upload data, and no data can go to the cloud of a high magnitude during working hours. Have you heard that before?
So at that time, we use we upload the data to the data volume in Amazon S3, and then we also upload our files, the programs to the Amazon instance. And then we can run experiments. Yeah, we can run programs in AWS, but we didn't have high requirements on bandwidth at that time.
You didn't have high performance?
I mean, we didn't have the requirement, the high requirement on bandwidth or capacity.
Oh, that's interesting.
Improved.
Yes.
Yeah.
Yes.
Well, no, I don't know about that, because we had our meeting last
I
week.
thought he was saying,
Yeah.
we do or we don't have high bandwidth.
I guess they never talked to you about that. He was saying that the volume of data coming out of our instrument going right to S3, it should be going to S3 or wherever, NRP. But that we have to schedule it from like 11 o'clock at night till 5 in the morning, which means we have to, which is okay. We just,
So yeah, have you tested if you can upload any files to the data volume in Amazon S3?
no, because we're not hooked up yet, because sponsored research and legal contracts and all.
Oh,
But
okay.
we're almost there, and once we're there, we'll hook the SES station to S3.
Yeah, yes.
But in setting up this whole
Yeah, and
they were telling us that we actually have to schedule, which
yeah. I mean, once you once you purchase the data volume from Amazon S3, you also need to mount the data volume to the Amazon instance, EC2 instance, so
Right.
that you can run the program on
right.
EC2.
No, that part I get. That part I get, but it's actually
Right.
it's actually the FASTQ files coming off the instrument, and they could be terabytes and terabytes. We don't know yet. We don't know how much we're going to be using this,
Yeah,
but
I
the
think, I think your data set is, it's larger or is bigger than ours. At that time, we collected the social media data. We collected data from social media platforms like Twitter.
oh,
Reddit.
that's different because you're pulling from internet to internet.
Okay.
We're going from directly from campus to S3.
You basically, we can use the command such as SAP to upload the data to the data volume in Amazon S3.
Well, I might have to talk to you because we had to have a huge workaround because it's on automatic dump mode. That's all the instrument offers. So we actually had to buy a NAS connection to, and that's now going to be programmed from that to a high-speed computer.
Mm-hmm.
But we're going to have to actually schedule our data dumps from 11 to 5 in the morning. Yeah.
And
well,
also you may need the key to access the instance or the data volume in AWS.
yes.
Yeah, the key.
Actually, so the data will be processed and the processed data will probably be in the instance, you know.
Yeah,
The instance will run the pipeline. The pipeline, I know exactly what has to be done in terms of science, but and the programs, we're gonna have to pull all those programs in. But it's gonna be intensive pipeline about, you know, for gene alignment, cutting the adapters off and all that, and finally to process the data.
Yes.
Maybe 7 softwares.
For softwares, basically, I mean, for software, basically, the instance has the software installed.
Yes, you need
but
to run this, yeah.
Yeah.
So yeah, we're really gonna need your help on that.
Yeah, I can try to provide the help.
So this is great. We'll do both. We're gonna cover all avenues. We'll do NRP, which would be great practice for all of us to kind of know
Yeah,
all of these tools.
Yeah, if they allow you to use the resource from NRP or even a cluster or a server or even a server, then it can save the cost. But I'm not quite sure. It depends on the data. They are required.
I also have to tell you, AWS, we get a government discount for AWS, but it's from Omnia, OMNIA. And I'll show you exactly what we need to do. It has to go through every legal department here. And that way you could not pay $1,000 a month, maybe less, you know?
Yeah, probably less. And also sometimes, you know, if you run experiment or run programs on AWS, probably your program may run for a long time. You know, in that case, you may not stop your instance. You may even keep it on the whole day. So it will cost more. Yeah.
That's actually correct.
All right. We're running out of time. So let me just say one last thing right here. One of the interesting things that we want to consider, especially when we're working with our graduate students, is encouraging them to add in a data science AI prediction models to the work that they're doing. Last semester, or last year rather, I was working with a student. He was predicting water consumption, and he wanted to add in AI model to do the prediction as well. And so there are lots of small spaces and lots of big spaces where these AI tools can come about and can find uses in the classroom for us in research, but also helping young researchers as well. And so I just wanted us to keep that in mind as we're going about working on doing our work.
I have one last question about a prediction analysis. You do training modules. Can you like train it and give it the answer? Like, for example, water consumption, like train it from historical data?
Yes, so generally speaking, that's how it's done. So you have to have a thing that's completed, i.e., you know what the outcomes are and what the inputs were, and then you use it to train on historical data, and then it'll be able to predict using new data going forward. Okay.
Yeah, thank you so much. Yeah.
Yeah. So but like for example, for the folding for the alpha folds, what happens? The process is they looked at lots and lots of what's that again proteins that had been folded, and what they did was they broke them down into smaller slices, and then they analyzed the proteins. They looked for different connections between the proteins and similarities and dissimilarities in their how they fold. And then what happens is that if you give it a new protein or a protein that's like other proteins, but as it slices that protein up and then it compares it to other mini proteins that it already has and uses that to predict how it will be folded.
Does AlphaFold replace the need for crystallized structures?
That I do not know. That I'm not a chemist. And so normally what happens is that you have to explain to me exactly what a crystalline structure is, and then I do some research and I can come back and tell you.
Okay.
But
I mean,
but
it's a huge advance in AI using AlphaFold. Oh.
yes. Yes, Dr. Nelly sent me a protein and I was able to run it on there. And I think the what we got was pretty close to what they have. It's a well-known protein. And so it was able to do it very well. So I don't know. Like I said, I don't know the chemistry of physics. All I know is the research I have on what they have on there. We have to work together, basically.
Right.
That's the point.
Okay, great. That's going to be a tool that the entire College of Pharmacy is going to need, yeah, for docking and drug discovery,
Indeed.
Yeah.
All right,
AlphaFold
so
for docking and drug prediction.
yes. So AIM got 2 minutes. Anybody else? Quickly jump in. All right. So basically, reach out. We will see if we can set up some time to meet, and then we can sit down and talk about exactly what's going on, and then we can go from there. So I will send out an email to everybody for this meeting, along with the recording like we've done in the past, and then all you need to do is hit reply.
Thank you so much for all you're doing for the Institute of Public Health and COPS. Thank you so much. We really appreciate this.
Thank you.
Yeah.
I'll go back and look at the tapes. I did not get to see. You have them right.
He'll send them on.
He'll
Yeah.
send it. Thank you.
Thank you.
All right, well then,
Right here. Says Lee.